Good morning, everyone. My name is Neha. I'm Principal Applied Scientist at Core 42. And as Natalia mentioned, I'm part of the team that has co-developed the JACE large language models, which are actually Arabic-centric, but bilingual large language models. Why bilingual? They are both Arabic and English-speaking large language models. Going over a bit of background, maybe this particular audience that has come to the workshop does not need to be motivated, but just so we know why we have trained an Arabic speaking LLM. First of all, Arabic is one of the most spoken languages around the world. It's 422 million people now that speak Arabic. And it's spoken over a large number of countries here in the Middle East, as well as in Africa. There are more than 30 distinct dialects, and it's actually the fourth most used language online. That said, as was mentioned also in the introductory remarks, the amount of Arabic data that we have online is actually quite limited as compared to the abundant English data we have. So 1%, in fact, the other side is that the 1% of all online content is in Arabic. So just a comparison, we've been spending a lot of time and effort on collecting Arabic data from various sources over the past several months. And what we have so far is something of the order of 120 or 130 billion Arabic tokens. Compare that to trillions of English tokens that's just abundantly available on the web. Because they are abundantly available, a lot of the large language models that are extremely prominent mainly focus on English and other very abundant European languages, and that actually makes this problem more prominent. The point is to build a specialized LLM which can be used on Arabic language. One part is to bring generative AI to the Arabic-speaking community. And second is to supercharge Arabic NLP applications that could use this LLM to generate a better user experience. On the Conda Galaxy supercomputer, which is built with collaboration between G42, which is the parent company of Core 42, and Cerebras, we have, together with Mohammed bin Zayed University of AI, which is the AI university based in Abu Dhabi, we've trained JACE and JACE Chat and released them open source on Hugging Face, together with demo playgrounds where you can go and test the model. Our 13 billion model was released in August of this year, and our 30 billion was released in November of this year. The amount of data we've trained it on, we've had English and code data, code being much smaller than English. 13B was trained on 279 billion tokens of English, while Arabic was trained on 116. So this is a little bit more than, so it's roughly 1x Arabic, 2x English, and 0.4x code, right? So this is the amount, this is the mix with which we have pre-trained JACE, and after this, Joel will talk more about JACE's pre-training. Then we have fine-tuned these models with far less fine-tuning data, but also among a mix of English and Arabic. And similarly for JACE 30B, which has more pre-training data, but roughly similar. In terms of applying JACE, a bilingual model like JACE, a big focus area for us is to apply it to education, particularly Arabic language education, have cross-language information retrieval and cross-language conversations based on that information. Bilingual content generation, because as we've seen in the Arabic-speaking world, there's a lot of intermixed usage of Arabic and English in large number of documents and so on. And multilingual text summarization, where you have data sources from both Arabic and English, and you want to generate a consistent, exhaustive, cohesive summary in one of your target languages, either English or Arabic. This is an overview of the JACE process. Our pre-training is bilingual, mixing Arabic and English. As I said, the talk that follows will talk in much more detail about this. One extreme would have been to train the English-only LLM, point near to that extreme is 95% English, maybe 5% Arabic. And in this case, the model would have been dominated by English and essentially kind of forget Arabic. Or that 5% Arabic wouldn't have meant much for the model other than being able to understand Arabic, like most of the LLMs you see now. The other extreme, which actually, interestingly, we started out training, is only 5% English and 95% Arabic. But the problem here is that Arabic data is too scarce, so you cannot really expand the size of the model. You're limited in terms of its capabilities of reasoning, downstream tasks, and so on. The best trade-off that we have found, and this is after a rigorous study of how to mix the two languages, is 2x English and 1x Arabic. This talk will mainly focus on stages 2 and 3, fine-tuning and alignment, and I will go into a little bit of detail on both of these steps. Evaluation will then be followed, evaluation of these models, both after pre-training and fine-tuning, will be followed by Professor Preslove's talk. So considering that J's model is already pre-trained at this point, now we have to instruction tune it to make J's chat, right? It has seen 1x Arabic, 2x English, and 0.4x code. And now we want to do supervised fine-tuning. So the first thing we did is that we took a lot of English instructions from the web. We know that there are a large number of open source instruction data sets available. Many of them have been created using heuristics like NLP data sets have been verbalized, or different kinds of other, like you crawl from Stack Overflow and you create an instruction data set of questions and answers and so on. Some has been created by human effort, and also a large number of instruction data sets today are generated using OpenAI APIs and so on, are collected from user conversations on ChatGPT. So we've collected all of such tasks, all of such data sets, and created our English instruction data set with about 6 million instruction response pairs. And then we've also spent some time and effort constructing Arabic instructions. We have, of course, used heuristics on Arabic NLP data sets. There is GPT-4 generated Arabic data, because as we know, GPT-4 is multilingual already. But a lot of our data also comes from machine translating the English instructions, right? And I'll talk a little bit more about that. So we have a good mix, but most of it comes from NLP tasks when it comes to Arabic data. A lot of it is miscellaneous, like human-generated or general miscellaneous tasks. Some of it comes, in fact, from search engines. We've inserted some amount of safety data and a little bit of region-specific data as well, which targets region-specific alignment questions. What we get after fine-tuning with these 6.1 million English and 3.9 million Arabic instructions, so overall about 10 million instructions, is a chat model that is capable of following instructions in both English and Arabic. In fact, even though we do not explicitly insert such data in our fine-tuning, it is also capable of continuing a multi-turn conversation that spans languages. So if you ask the first question in English, up with a follow-up question in Arabic, it can still answer those questions. Some degree of safety and cultural sensitivity has been baked in during the fine-tuning process, but of course this is a work in progress, and we want to continue to improve this aspect of JACE. So how did we localize instruction data sets? When I say localize, I mean make it more specific to the Arabic community and to an Arabic-centric model. The first way is to, of course, machine translate. We have a machine translation model that is trained on a lot of data. And we use this model to translate the English data sets. Some challenges that we face during translating is translation of code, for example. Our MT model developed in-house is capable of very good translation, but it has not seen code data in its training because it was trained mainly for a conversational chat system. So it has not seen a lot of code data, and therefore it cannot handle code data, and it translates maybe Python code or Java code into Arabic. So you have function names being translated into Arabic, which is clearly not good. So you have to remove such code data using regular expressions or something. Then another problem, which is actually Professor Preslow's favorite problem, is that AI as an acronym is expanded into this Arabic string, which means Amnesty International during translation. Other decoder typical behavior, like repeating the same character or word, falling into a kind of, you can say, mode collapse, where it just constantly produces the same kind of string, is also seen, which we had to kind of filter, get into an iterative data cleansing process, and clean out all of these problems using keywords, keyword filtering, or other kind of heuristics. The second main thing about localizing this instruction data set is that of cultural sensitivity. So essentially, you can see here an example where it does not mention that it's asking about the UAE. It just directly asks what are the guidelines for obtaining a telecom tariff approval from TRA, right? And the assumption is that one is talking about the UAE because this model is based in the UAE. So it's just one example of cultural sensitivity, because just like Google search, where you are using this model determines the default behavior of the answer that you desire. So we have actually spent some time towards manual curation along culture, UAE history, geography, in fact, of the region, not just UAE, local laws, and religious sensitivity. And constructed a few thousand QA pairs that we have included in our instruction data set. We've also done other ways of creating data sets, like verbalized Wikidata relationships. So starting from entities of interest, like you start from the Wikidata entity of UAE or Wikidata entity of, let's say, Sheikh Zayed, who was the founder of UAE, or the region. And then you travel 2 hops along from this node. And for each subject predicate object relationship you find along these 2 hops, you verbalize that relationship into an instruction response pair using heuristics. We've also done some self-instruct methodology for this domain with GPT-4 and constructed some data sets to be included into our model. Finally, that of persona. So I recently saw a tweet about, will all LLMs now say that I'm ChatGPT developed by OpenAI, right? So this is one problem which happens when you train with GPT-generated data, because oftentimes the model will say that I am, GPT-4 or ChatGPT trained by OpenAI. While this can be controlled by prompt, we also found it safer to filter out such examples and explicitly insert a persona so that the model identifies as Jace, with or without the prompt. That is the prompt controlling its persona. So for supervised fine-tuning, this is what our data set looks like right now. We have an instruction, we have an optional input. It's not always there. Sometimes the instruction by itself is capable of providing all of the information needed to generate the answer. And then there is an output. The way we formulate this is using markers. So hash and an instruction marker, similarly for internals. We do loss masking in that we do not apply or attribute loss and do not backpropagate loss on the tokens related to an input, but only on the tokens in the response, excluding the response marker. One interesting thing, when the Llama 2 paper came out, it talked about packed fine-tuning. Until then, the default method to do fine-tuning was, instruction fine-tuning was to go with unpacked, which is in a given sequence. So let's say your max sequence length is 2048, and together your instruction input and output cover something like 100 or 200 tokens. Then you will just pad the rest of the tokens and train with that, right? But following the packed fine-tuning experience, we also implemented packed fine-tuning for ourselves. And in this case, what will happen is we'll insert these special separator tokens, that is the red ones, and the instruction input and output tokens will be packed together into the same sequence until they fit. Of course, we'll not break up an example. So if there is any space left, like you see on the right here, those will just be padded. So one other thing to do here is attention masking, so that these particular output tokens do not attend to the instruction and output tokens of the previous example, but we allow the separator tokens to act as implicit attention boundaries, similar to pre-training. This is how model pre-training is done. And we've seen that this actually works. Not only do we get a much more efficient fine-tuning, because remember, when you pack more examples into the same sequence, the effective number of sequences you get is much smaller. We get an 8x reduction in the number of sequences we must train with. And not only that, but we also see in downstream evaluations in LM harness, we actually see in both English and Arabic improvement with packed fine-tuning. Also, this allows us to directly fine-tune for longer context lengths. As we'll see in the subsequently, JS is trained with alibi positional embeddings, which allows it to actually extend it to as many tokens as you want in its context. And because we are doing packed fine-tuning, so a model that is pre-trained with alibi embeddings can then be packed fine-tuned to as long a context as you want, to directly extend it to very long context lengths as well. In fact, fine-tune it for those context lengths and make it improve at those kind of long context examples. After the supervised fine-tuning phase, we actually released JS Chat. This is accessible at arabicgpt.ai. So please go ahead and register and use the model. We welcome any and all feedback. Our model is also available, both models, actually all 4 models at both sizes, Foundation and Chat, are available for download at and on Hugging Face directly for use, as well as there's some sample code to get you started. These are some examples from our release of how we actually write a question in English, and this is a very common scenario for people living in the UAE who are not Arabic speakers, and they want to write something to someone, but the person they want to write to are essentially Arabic speakers and don't know English. And here we are saying that, can you write an email in Arabic asking my landlord to reduce my rent? And it writes an email in Arabic, right? So this is a multilingual conversation I was talking about. The other very interesting thing is that of who is Zayed al-Khair. So Zayed al-Khair is not a well-known English phrase, but in Arabic, it is used to refer to Sheikh Zayed, the founder of the UAE. And Zayed al-Khair literally means Zayed the generous. And JS, although it has not seen this phrase in English, it has likely seen this phrase in Arabic, is able to use the cross-lingual transfer to generate this knowledge in English as well, which shows the main power and advantage of a bilingual LLM, in that it can absorb knowledge from both languages and bring it into the same space and essentially give you a union of the knowledge that it acquired in both languages. So we released JS, and here are some observations on our user base and user experience on JS. We have a significantly more number of distinct users in Arabic. So JS has invited much more engagement in Arabic than in English, although it's Arabic-centric, but it has more English data in its training. JS is actually very competitive in English as well, with models of its size. Yet it has excited interest mostly among the Arabic NLP community. We have a significantly larger number of Arabic QA than English. We have a feedback system in the playground where you can give a thumbs up or a thumbs down to JS's responses. And a large number has been unmarked, but our observation is that unmarked responses are usually okay. So we've seen about a little bit more than 10% negative feedback in Arabic and similar in English. And for about 1,000 in Arabic and 376 in English, the user has actually given us a suggested answer as well, which is another possibility while using the playground. The other very interesting thing that you see in this histogram is on the x-axis is the number of turns in a conversation. Our longest conversation lasted for 187 turns. And this is the number of conversations with that many turns. And blue is Arabic, green is English. And we see that overall, the amount of engagement or the average number of turns that a user will have is larger in Arabic, which means Arabic has also invited much more engagement. So this is particularly interesting because remember that even though JACE is Arabic-centric in that it is built with the motivation to build the best possible Arabic model we can build, it is actually still seeing double the amount of English data than Arabic data. And yet the amount of engagement we see in Arabic is more. So moving on, we have actually done some alignment. This is as yet internal work. We'll shortly be releasing or uploading into the JACE playground after our work on alignment. So we have mainly focused on two axes for alignment. One is safety and the other is helpfulness. We've trained reward models on a much smaller version of JACE. So this is 1.3 billion parameter model of JACE, also seen the same proportion of English and Arabic data. We fine-tuned the reward model on two open source data sets in English for safety and 3 open source data sets in English for helpfulness. We've translated one of these to Arabic in both cases. So with the English data set and the Arabic data set, these are preference data sets where given a question, the answers are ranked by safety or helpfulness or both. And we've trained separate models, separate reward models for safety and helpfulness. Now, using this model, we have then implemented rejection sampling, similar to the Llama 2 models. So we've collected a set of 160K prompts. This is a combination of prompts from our database of JACE chat, which I was talking about earlier, and the test data sets of the open source prompt data sets like HHR, LHF, PKU, and SHP. On 160,000 prompts, we have generated 10 samples per prompt. And for each such generation, we have ranked them with the reward model, both for safety and helpfulness separately. Selecting the best model, best response, one for safety, one for helpfulness, we have actually launched 2 separate supervised fine-tuning for one epoch with the selected sample. So we have now one model aligned for safety and one model aligned for helpfulness. And one interesting thing we see here is that this is focusing on safety, this particular chart. On the x-axis is the number of samples we generated. And on the y-axis is the average maximum or the average median reward model score, right? And this is before, the dotted line is before our rejection sampling and the solid lines are after, right? The blue is the maximum and the green is the, the green is the maximum and the blue is the median. Now, what we see here, first of all, is the gap between the green and the blue reducing after rejection sampling. And secondly, overall, the median and the maximum have increased. So it shows that the effectiveness of the rejection sampling training itself in aligning to the reward model, if the reward model actually represents a true preference. These are some further on safety and helpfulness. So this is on the top, you see the model that has been trained for safety, and it's evaluated along both safety and helpfulness. So the reason we did this exercise is to see that when we align for safety, do we compromise helpfulness, right? And on the bottom, when we train for helpfulness, do we compromise on safety? So our observation is as follows. When we aligned for safety, these are JACE 13B models, actually. So when we aligned for safety, we actually ended up compromising helpfulness, which actually ties in to the literature as well. So on the red, you see the number of times that supervised fine-tuned model that is before alignment 1, and these are GPT-4 evals. And the green is where the aligned model 1, right? So we see similar numbers in English and Arabic. So when we trained for safety, our safety definitely improved by a large margin. But at the same time, helpfulness was compromised. So the supervised fine-tuned model was generally much more helpful than the safety model. Coming to helpfulness, I will focus on the right bottom quadrant first. The model aligned for helpfulness actually improves a lot on helpfulness. But on safety, it's actually not that bad now still, right? So remember that this SFT model already has some safety baked in. So once we align for helpfulness, this is like a 50-50 almost, win percentage. So what we find is that training for helpfulness is actually the better option because we can actually improve helpfulness without really compromising safety too much, right? And that being alignment, this is where we are at in our JACE roadmap. We have the following plans, near-term, medium-term plans. We want to improve the model, although it already accepts long context and is able to perform to some extent well on longer contexts. It won't crash for sure unless you run out of memory. But we are still trying to improve its performance on long context using fine-tuning. We are trying to build JACE for Arabic dialects. As we know, Arabic is actually, the written form of Arabic is different from the spoken forms of Arabic. The written form is modern standard Arabic, while hardly anyone other than news channels speak in the standard Arabic, that is the written form. Everybody speaks in the dialectal form. And today, with more and more informal communication over social media and so on, the dialectal form is actually also used for conversational systems, chatbots, and people expect speeches to be written in dialectal Arabic, for example. So we want to train JACE, although it is already able to understand most Arabic dialects, it still has some way to go when generating Arabic dialects, and we are working towards this. One challenge is that Arabic dialects are not very well defined, the dialectal boundaries, how many dialects there are, and so on. Finally, next we want to train the JACE family of models. So we have, as I showed before, our smallest model is at 13 billion parameters, and we realize that many people in the developer community may or may not be able to easily have the hardware to run a 13 billion parameter model, let alone a 30 billion one. And so we plan to train smaller models, which we've already trained. We plan to release them shortly after instruction fine-tuning and rigorous testing. We want to adapt JACE to different use cases. One example is summarization, and here, I'm talking about multilingual summarization, like you have Arabic news as well as English news. The idea is to collate news from both languages. Collate news from both languages and bring a single concise summary to the user. We're planning to extend these thoughts to JACE in other languages as well, and I'm sure we have a lot to learn from other speakers in this panel. And then adapt JACE from there to other domains like legal or healthcare. Finally, we'll, as we've seen, this demonstrated success of MOE. We'll also plan to, like a lot of these, steps like dialect or, different tasks could benefit from the MOE architecture. So we'll also explore this in the future. So that's the roadmap for JACE, and thank you very much. That is the end of my talk.